Alright, in this video I'm going to talk through this word problem that you see on the screen here. And this came right out of the textbook. It was a homework problem that I assigned, and I think what could be helpful is just to kind of talk through one of these, especially since I can't have class right now. So first thing, you got to read through it. It gave you a picture already, which is practically cheating. So there will be problems where you have to create the picture. It's always important when you're reading a word problem to kind of decide what's important information, what's not important information. Sometimes you have too much information or not enough. So, and then always going back to what the questions are. Now, I formatted it really in a way that's pretty clear about what the questions are, which makes it a little bit easier. So this is just kind of a stepping stone to get into problems where you have to do more. So here we go. We got a yacht, which is a boat, a really big boat, and it's leaving St. Thomas. It looks like it's over here. And it's bound for an island in the British West Indies, which is 200 miles away, and that's reflected in our diagram here. It says it's maintaining a constant speed of 18 miles per hour, but encountering heavy crosswinds and strong currents. The crew finds after 4 hours the sailboat is off course by 15 degrees. All right, it's actually pretty common. A sailboat's not going to, sail in the straight direction. It's going to have to go back and forth. But regardless, it's just a word problem. We're making this up anyway. So the question says, how far is the sailboat from the island at this time? Right, so we've got this little diagram. Looks like it's supposed to go from St. Thomas to the British West Indies. It's pushed off course by 15 degrees. It's represented in this little triangle they drew. And here's the boat. If it keeps going in that direction, it's going to miss the British West Indies, right? So it's got to turn, and the first question is wondering, well, how far away are you from the British West Indies? So what I'm going to do, I'm going to move this paper up so that you can't see everything, and I'm going to redraw this picture so that we can kind of start working on this and make sense of it. All right, so we've got our starting point. We're going over here to the British West Indies. It's off course a bit, and it's got to go that way. So none of this is to scale, right? None of these pictures. And this dotted line, by the way, represents just where it would be traveling if it kept going. So we got the 200 miles here, and we got 15 degrees. And the reason I'm redrawing it like this is because we're really trying to get it to be a triangle, because we can solve triangles for sides and angles depending on the information we have. All right. So the other bit of information that we were given in this problem that isn't already labeled is that it was traveling at a speed of 18 miles per hour. Speed of 18 miles per hour. That doesn't make sense. I just found a typo. 18 miles per hour. And it is for 4 hours, right? So for 4 hours, it's traveling in this direction. That's a little bit off. So to figure out this distance then, we're just going to take the 18 miles per hour and multiply it times however many hours it was, which is 4. And then the hours units will cancel, and you will get 72 miles, right? So that part you need. 72 miles is how far it traveled. And the first question says, how far is the sailboat from the island at this time? So right off the bat, I'm looking for this distance here. I'll just call that distance x. Could call it anything. I'm calling it x. All right. So I need to find x, not surprisingly. And to do that, I have to recognize what type of triangle I have. It's not a right triangle, as far as I can tell. I don't know what these two angles are, although we will end up finding this one. So since it's not a right triangle, as far as I can tell, I have to use either the law of sines and the law of cosines. This is a side angle side triangle because this angle is trapped between the two sides. So because of that, I'm going to use the law of cosines. So it'll be this side squared equals those two sides squared. Well, I'll just write it out. It'll make more sense. X squared equals 200 squared plus 72 squared minus 2 times 200 times 72 times the cosine of that angle, 15 degrees. All right. So it works out perfectly for the law of cosines. I'm kind of rushing through this because I've already worked it out. But if you plug all of that in the calculator all at once, 200 squared plus 72 squared minus 2 times 200 times 72 times the cosine of 15 degrees, make sure your calculator's in degree mode, you get, and I rounded it to two decimal places. Let's see, what's that? 17,365.34. All right, and I rounded it to two decimal places for all of these problems. Took the square root, and you get, let's see, 131.78 miles. So, how far is the yacht? to answer question A, right? Can you see this on the screen? Let's see. The yacht is 132, I guess I could say about 132 miles away from British West Indies. Okay, so that's the first part. And that's not so bad. So question number 2, or question B, through what angle should the sailboat turn to correct its course? And this is actually a deceptively tricky question depending on how you think about it, all right? Through what angle should the sailboat turn to correct its course? Okay, so this is good. This unit kind of leads into vectors. So because it has direction, right? So this sailboat's traveling from St. Thomas in this direction, all right? So it would be continuing on this path going this way. So the question is asking, which way does it need to turn? It's going to need to turn some amount of degrees towards the British West Indies, right? So that's this angle here. What angle should it turn? Now the thing is, I don't have a method for solving for angles outside of the triangle, right? I have a method for finding angles that are inside the triangle, which is what I'm going to do. And there's a little bit of a trick to this. So I need to label this angle right here. I'm going to label this angle capital B just because. And I've got methods. I got 2 different methods here to do that because at this point it's a side, side, side triangle because I just found that side, right? So this could also be an angle side, side triangle depending on how you decide to think about it. So I could use the law of sines or the law of cosines at this point because I have that angle and I've got multiple sides to choose from. If I use the law of sines, okay, if I use the law of sines and I try to find this angle, I have to remember that the law of sines, when I do sine inverse there to find that angle, I can only get angles between negative 90 degrees and 90 degrees. And I made a video on that and I talked about which angle, finding the other angle there. Now this one looks like it would probably be obtuse. So I need to think about that. So I'm gonna rush through that law of sines real quick and show you exactly what happens. So I would do the sine of 15 degrees, right, over the opposite side, which would be x. I just found that. So that'd be 131.78. I'm gonna go back to that more exact value, equals the sine of b, which is what I'm looking for, over, what would that be? Sine of b over 200, right? Okay, when I do all that, I get the sine of b is equal to approximately, I guess I should write, 0.3928, okay? And then I have to do sine inverse of that value. And I get, that's what b is supposed to equal, okay? The problem is, when I get that answer from the calculator, I get 23.13 degrees, right? And then I have to remember, and again, this goes back to a previous concept, sine inverse only gives you angles up to 90 degrees, right? So it's never going to give you an obtuse one. So how do you find the other one? You do 180 degrees minus that, which would give you 156.87 degrees, right? Now there's actually an infinite number of solutions for that, but again, going back to that other video, I got to get both of them. So now I've got both, right? And I'm going to go back to this drawing again. Which one kind of makes more sense in this particular drawing? The 156.87 degrees. The 23.13 degrees could make sense, but that turns out to be this angle here. So these are actually supplementary angles, meaning they add up to 180, right? So the angle that I wanted to find when I use sine inverse, it actually gives me this one. And it turns out that's actually the angle that I want anyway. I actually want that angle because that's the angle in which the boat needs to turn towards the British West Indies. But I just wanted to kind of point that out because if you were to find both, this is the angle that's inside that triangle, and this is kind of the one on the outside, or an external angle. So our answer is the boat must turn 23.13 degrees towards the British West Indies. All right. Oops, sorry. I just abbreviated that as BWI. which is also an airport, funny enough. Okay, so then what about if I didn't use the law of sines there? What if I used the law of cosines? If I did the law of cosines, right, I would have the thing that was missing. It'd be almost the same setup as this, except in this, some of these numbers would be jumbled around. I would be finding an angle. So the only angle in the law of cosines is the one on the very end, and that would be B, which would mean that 200 would go in this spot, 72 and 131.78 would go in these spots here, and you'd be solving for B. And when you did cosine inverse, your answer would be that angle, and you would get 156.87 here. And then you would have to say, wait a second, that's not the angle we turn. The angle we turn is the one on the outside, so you'd have to do 156.87 or 180 minus 156.87 to get you that 23. So you could use the law of cosines in that one, and you would maybe you would have to think less. You get to choose. I tend to think that the law of sines is pretty easy to do. It's less calculation, but you do have to think a little bit harder when you get over here. All right, so let's jump into the last piece of this, which is part C. How much time has been added to the trip because of this? And we're assuming that the speed remains the same. So what I need to do is I need to figure out how much time it takes to go the original path, right? Just the 200 miles. So the way you do that, this is part B over here. Part C, I guess I'll just do right here. So we have the original amount of distance, which is 200 miles, and I'm just going to divide that by the miles per hour. 18 miles per hour, giving me 11.11 hours, and I'm rounded to 2 decimal places again. And I needed to compare that amount of time that it would take. It would take that long, traveling 18 miles per hour, to travel 200 miles, right? That's the original route. And then the other way would be I'd have to travel the 72 in the wrong direction, plus the 131.78 miles to correct it, which would be a total of 203.78 miles. So I just need to take 203.78 divided by the 18, I guess I should put units there, miles per hour, which gives me 11.32 hours. And then the last thing to do is just to compare those two. So I'm just subtracting 11.32 minus 11.11, giving me 0.21 hours. So it would add 0.21 hours to the trip, which that turns out to be 12.6 minutes. Not too much. Kind of surprising, actually. But you're only off 15 degrees. So that's how much you would add to the trip. Okay, so this is a pretty common problem. There's a lot of components to this, clearly. That just took me 13 minutes to explain. So I hope that helped. If you need to rewind and go back, or maybe it would be helpful to look at the example problems that are in the textbook as well. I hope that helps. Take care.